It's inconsistent when
It
it
is. We're gonna do it at
starts.
one
No, no, no. This is more funny.
Is it? No,
Yeah,
it's
some
not
people might
funny.
even chuckle.
Okay. Martin and I are doing module 14 on your own. So we're starting with 14.1 because that's where you should start. Martin, will you please read us 14.1?
Two containers are filled with the same mass of both nitrogen and hydrogen gas. If the first container is significantly larger than the second, in which container will the reaction be fastest? Okay, it's going to be the second one because then it'll have a higher concentration.
Yes. Okay. So the reaction will occur faster where the concentration is higher. What principle are we following?
It's the one on page 463.
Right. So some principles of reaction rates, right? How we can increase the reaction rate. Another way would be what? Temperature, right?
Yep.
Increasing temperature and decreasing the concentration decreases the reaction. So they're positive, they relate to each other positively. Yep. What is 14.2? Here we go.
The muscles in an animal's body are run by chemical reactions. When these reactions occur, they contract the muscle, making it move. A biologist is studying a lizard and notes that when the lizard is in a cold place, it moves very slowly, but when it is in a warm place, it moves very quickly. Explain this observation in terms of chemical kinetics. Okay, first of all, any biologist should know that because lizards, I know that lizards are cold-blooded and I'm not a biologist.
Sure, but explain it in terms, what did it say? Explain it in terms of chemical.
Well, the rate of a chemical reaction depends
kinetics.
on the temperature.
Okay, so what do we mean by kinetics?
We mean, well, you see kinetics. Wait a second.
This whole chapter is on kinetics.
Well,
and where is it defined? It's going to be defined near the beginning.
It's not defined anywhere.
Of course it is.
No. Kinetics is like energy, I think. So, like, this is pretty simple. It's the same principle as the first one.
We must also look at how fast the reaction can go. Even if the reaction is thermodynamically spontaneous, if it doesn't proceed quickly enough, there's no use running it. Okay, so we're studying how fast a reaction proceeds. Okay, we call that a study of reaction kinetics. So chemical kinetics is how fast a reaction proceeds.
Yeah.
So as you said, there were principles on what page?
463.
And those principles relate to kinetics, how fast a reaction can proceed. So you said that if the concentration is increased, right, as it would be in a smaller container, then the rate of the reaction is increased. Yeah. We also saw that if the temperature is increased, then the rate of the reaction is increased. And so that is this chemical principle in action here.
Yeah.
Right? So when we are asked to explain it in terms of chemical kinetics, when we're asked to explain it, we have to know what that means. Yeah. So the kinetics is how fast a reaction can proceed. So since chemical reactions will speed up at increased temperature, then that's how this explains it, right? When it's warm, the chemical reactions increase their rate. Mm-hmm. When it's cold, the chemical reactions decrease their rate.
Yep.
Okay. Any questions on those two on your own?
Nope.
Enjoy yourselves, friends of chemistry.